Oh yeah. I mentioned I had just been to Doug Lennett talk, and so I mentioned what he did and what I thought it implied, which I thought was really interesting. I can try to give you the Cliff's Note before Stephen arrives.
Sure, yeah.
Doug's been working on basically common sense reasoning. He's been doing it with a pretty full higher order logic language with frames. What's interesting is we know that's hard to compute. So what he does is compile the higher order logic statements into lower order logic statements, which are easier to compute. Not sure exactly what the lower order logic is, but probably something akin to data log.
And what does he mean with hard to compute? I mean,
higher
yes,
order logic is,
yeah, it's not computable, I know, but in general it's not, but probably in all the specific cases it is, I guess.
Yeah, but I mean, in all the specific, the algorithms you use to compute them are extremely demanding. Like if your either algorithm is only doing very special cases, and then it's not a full higher order logic algorithm, or it is a full higher order logic algorithm and it's slow, even if it's only doing the possible subset. Because it's geared for the higher order logic, it's slow. Okay. And he, interestingly, he said, oh, we even have a full higher order logic theorem prover. And we noticed that in practice, we would never use its results. It always came too late. And it rarely added something significant to what the lower order stuff was doing. So what he does is he has contextual micro theories. So he has, like, we're in this context, so these are the micro theories that are known in this context. There's no notion of global consistency. You only have local consistency within a micro theory. And then within the micro theory, you have a very simple problem solver that works on that micro theories assumption.
And are these micro theories connected somehow, or are they isolated?
Yeah, they're not isolated. They're not explicitly connected. Like there's overlap. Hi, Bentley.
Hi, Bentley.
I was just running through the Lennett story quickly for Felix since he missed it. He asked me what was going on when Friday, and I'm like, what was it again? I was too pregnant to remember.
Any insights how that relates to CDL?
Okay, what I think is extremely interesting is the notion of, okay, computation is out of our scope on the one hand, but I think that he's had to solve expression, and he's very clear that you don't want to do machine language, to code machine language, you want to code higher order computational languages. And for him, that means frames. Like he's extremely sanguine about, you know, think in frames and then compile down to data log triples, something, which he left a bit unclear. But the low level representation is not what you want to be working with. But you do want the low level representation to do any computation, any efficient computation. And one thing he did say also is that the problem with higher level things is that there's a kind of balance. You want to have enough high level construct that you can express things. But if you have too many of them, there's many ways to express them and you lose canonicality. And the obstacle he has in his case with losing canonicality is not not Tim's concern, but he's saying if you have multiple ways to express something, then you need to have rules to convert from one to the other. And those rules are insanely costly. Like they add ridiculous complexity to the system because, again, he's doing computations. So it doesn't matter so much as you think what upper level ontology you use. but be very careful when you find that something can be expressed in 20 different ways, because this is where doing the equivalences will kill you. Now, for me, that's kind of a necessary problem, in the sense that I'm looking at the fact that people express things differently and how can we reduce it? But the reality of multiple expressions is kind of the premise for my whole project. I don't have the luxury of training people into using a given upper level ontology, because I want multiple contributions. And Linnet, by the way, has a history of getting a lot of people very enthusiastic about his project and working and burning out. There's ridiculous churn within his organization, because adhering to whatever he's doing is difficult. Adhering to, you know, enough uniformity in describing things is extremely demanding. Now, I'm inferring here, like the churn is a fact. The inference that it has anything to do with the uniformity is an inference, but I think it's a plausible one. Jack actually gave me a lot of references on how some of that was used in Kindi, which was another great AI computation project, KYNDI. And there's tons of patents and stuff in Kindi, and a lot of the important people in Kindi left, but now they have to start from scratch with different principles because patents. Really interesting what's going on there. But I mean, computing thoughts has been a goal, and people have sunk a real ridiculous amount of money in it. And in a way, there's a lot of new stuff happening in that space, but of the old efforts, Linnet's OpenPsych is one of the few old projects standing. And that way it's admirable. I mean, there's this enormous rule base that he's constructed over the years with micro theories. And making that collective would be, again, computation is not my scope, but representation, and enough representation that you can compute equivalence and canonicality, which is, there's a lot of reasoning there already. But it would be an amazing achievement. But you know, I don't have Linnet's team and budget. I mean, he's been at it for 40 years, almost 37 years.
Yes, and this space is quite old, actually. Like
it is.
Yeah.
But the reality is he has he has results. He has a reasoner that can not only reason about common sense questions, but even justify the reasoning and even say, like, he's got to the point where if you have an expert interacting with the system and say, oh, how come you could not infer this? Well, there's this premise, which are halfway plausible to me. But if I had been certain about any of those, I could have inferred what you wanted me to infer. So which one should I hold to be true?
This is amazing in combination with crowdsourcing, because then people can add what's missing. Yeah, wow.
Exactly. That's wow, indeed. So then the expert can say, no, you can trust this one to be true. And so there's the work cycle of making these, building those rules and adding those rules in those micro theories is getting increasingly tight. So that's wonderful. So that was Linnet.
Is that an open project?
Unfortunately not.
Unfortunately not.
There's the ontology is open. There's something called OpenPsych, but that's just the ontology. It's not the rules, and the substance is the rules. But at least there's an ontology we can use. But as he said, he said, I pretty much published the ontology to show people that it was not where the problem was, that it was useless on its own.
Interesting. Yep.
Which again, this is very, very useful stuff.
So it's the rules and the algorithms, basically.
Yeah.
Okay.
Yeah. But I find it extremely interesting that he does this compilation. And again, if you're thinking of pandemonium type reasoning system where you have multiple agents, each working on micro theories and saying, oh, I think this micro theory is relevant and here is what it has to say. And then a kind of, I'm not sure this is how it happens, but this is how I would do it. And then something that says, okay, well, the micro reasoners that feel the most confident about their micro theory being applicable have this to say, and this is hence what I think is applicable here. And this is, again, wonderfully distributable in terms of a multi-society of agents, Minsky type project, right? So let's go back to CDL,
Yeah.
as you were pointing out. Still hoping for Stephen to come. I still think frames are the right way to do formalization. The notion of compiling it to a lower level I find extremely interesting and attractive. In a way, it's always what I'm doing when I'm reducing it to RDF, but in a way that very much preserves the structure of the frames.
Are frames compatible with our claim structure?
Frames, in a way, they very much look with what Tal was presenting, right? It's about saying, here's a class, and here are the slots of the class. Here's the constant slots and the variable slots. Like this is known, and this is, you know, depends on the individual, but there is something there for each individual member of that class, that kind of stuff. Is it compatible with our claims? Yes and no. Frames are mostly used for entities or action schemas. A claim is very much saying either, well, this entity actually has this property where the frame allows variation, or maybe saying this frame is not applicable because the entity varies outside of the variation space of the frame. Or it would be this action schema happened with those entities at that space and time, right? Those are basic claims, or this thing. Of course, then you get into the could happen, would happen if, blah, 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 blah. You get these kinds of, hi, Stephen.
Hey, Stephen.
I did a repeat of what I said about Doug Lennett Friday, because Felix had missed it. And then it's like, okay, how is this applicable? And I said, well, Doug's using frames, and our frames are close to what Tal's doing. Does it have anything to do with what we're doing as claims? And I said, frames are usually lower level. They're either entity or action schema. And that means our claims are either saying this entity fits that frame or not, or has this specific individual value for that slot in that frame, or this particular action schema did happen at that point, or could happen if some other action, or whatever, right? These, a lot of action occurrences, conditional and so on. So those I think are the basic claims. I'll want to get back to our earlier conversation about unification of compound claims, but let me first riff on that a bit. By the way, I hope you're all okay. Tim's not there. I'm in good shape, so I'd like to take over.
Yeah, sure, fine for me.
Okay. We spoke a lot about the relationship between claims and arguments. As in, this is a premise for believing that, right? There's other relationships. I spoke a lot about interpretation, and I'm speaking a lot with Jamie these days, and she has three basic relationships between claims. One is implicit, like implicit presupposition, but you know, I don't think there's a fundamental reason to distinguish implicit and explicit presupposition, because it's always in a specific elocution context, it was explicit, and in another, it was implicit. But if you want to look at it generally, the question is, do we have a presupposition for this claim? And implicitness is something that can be sorted out.
I guess contextualized claims can have that extra notation, like you said.
Yes,
that categorization only makes sense if you have the context of who uttered it.
Exactly. It makes sense to say in this context, this claim was left implicit explicit. And it's possible that a claim is claimed to be an implicit presupposition without any elocution context to support it, except if we consider the CDL system as an elocution context, which I would. It's like, okay, the moderator decided that this was an implicit presupposition. That's.
But why don't you just add it at that point, and what distinguishes it at that point from any other one?
Yeah, exactly. Well, the question is, what is the origin, right? When was it?
But that's what Tim keeps calling the decontextualized claims, right? The origin doesn't matter in the decontextualized claims, and in the CDL system, you would only store. Basically, it means that there's no use to have implicit and implied annotations on claims in.
Okay. Implicit. The implicit explicit distinction is not that important. I agree with you. Implied is something else. Implied is interpretation, right? This claim can be interpreted like dog whistles, right? This claim can be interpreted as also meaning this. And again, this is in a given elocution context, but if you abstract that out, it's about saying this can be understood from this. And this is a relation, and you can even put it on decontextualized claims. It's a relationship. There's many relationships. One of them is premise. One of them is let's call it interpretation, but I'm using often interpretation to say, what's the claim that is the interpretation, that utterance, but at quote unquote face value, as opposed to the one that is implied. So I want to be, I probably want to adjust my vocabulary here, and I'm still fishing for a word. Implied is good. So I'll keep implied. Then there's her other one is derived, and derived really are variants, right? And the variants are usually about generalization or specification of one of the entities in the claim. And now I'm realizing this notion of entities in the claim, I keep talking about, oh, by the way, when you formalize it, you have the entities in the claim. But do we need to formalize it? And this is what I'm realizing, and here I'm taking a page from you, Stephen. Can we have a link between a claim and entities which would have linguistic definitions, pre-formal definition, and saying those entities are involved in that claim's statement without saying exactly how they assemble into a formal statement, and just having the relationship of component entity in a claim. And then, it induces all kinds of interesting relationship between claims sharing the same entities. And there's everything that is induced from the links between entities and, like WordNet, hyponym, hypernym, blah, blah, blah. And all the things I said about distinction, right? Here are two conflicting definitions for a term, an entity term. How do they differ? What claim is held to be true in one definition and not in another? All these, I spoke about them in our general conversation, but they're much more applicable to entities than claims. And that way, I think making the claim entity relationship formal in our system is actually worth doing.
This is what I call context, oddly enough. And yeah, entities is one context, but I think it relates very much to what I keep calling as these hashtags I want to be able to add to claims, which in the majority of cases to be useful would be entities indeed. But I think we can look at it broader. But yeah, it sounds like that like the informal way, but still allowing to formally link these informal entities to the claims. Right. That's a base requirement for the base layer. I am fully on board with that.
Excellent. And by the way, I'm saying entities, and you say it may be broader than that. I am including predicates and action schemas in there, which may not be obvious. And so the idea is you could have in a claim, you would have, here are the component entities, and optionally in the other layer, here is how these underlying entities formalizations assemble in a predicate statement that is supposed to express the claim. But that would be another layer, and we could look at that perfectly independently and look at the component entities. And what is nice is the hypernym hyponym relationship, for example, between entities or action schemas would still allow us to navigate links between related claims, what Jamie calls derived claims, without having a formal representation. And this is what I want more than hashtags that way for these
yeah, it was
entities.
shorthand. It is more than hashtags. It's shorthand. I think I made some sketches in the past. I don't know whether you were in that meeting. But yeah,
oh, interesting.
I just would represent them as hashtags because it's something people know. But yeah, indeed, you need also relations between, like, this is a more specific form of the other one, etc., etc. Right.
And actually, what I was going to do right now is look. I'm pretty sure the WordNet system has been there must be an ontology for that. I was beginning to look at the ontologies for WordNet and that kind of stuff. And that's so yeah, so that's what I'm thinking about right now. Like, what are links between state claims? In a way, the conclusion is a link between claims, right? Because there's the argument as a linking between claims, and there's a premises. But I'm not sure that I'm hand waving a bit here, and I'm feeling bad. I'm beginning to be trying to be more formal about this, right? If you have the argument as a claim, and its conclusion, the premises are premises of the conclusion. They're not premises of the argument. That's different. That's the wrong level, right? If I make them premises. So the argument exists at another level. And of course, the interpretation of a given contextualized statement as a decontextualized statement is also a claim. But this is why I'm so wedded to topic mapping. It must be possible to say any of this can be a claim and hence contestable, but there is a level of analysis where we can forget about it and just say, okay, this is the relationship between the contextualized statement and its interpretation as a topic which has an expression, which is another linguistic statement, but which has all the decomposition into components and this and that, and relations, which would be at the concept level, not at the original sentence level. But we want to hide this distinction in most interfaces until it becomes relevant, until it becomes contested. And for me, topic mapping is about saying anything can be contested, but that also means that we can have representation where we hide the fact that this is contestable until it becomes relevant.
That makes sense, as it's just too much.
Yes. Making everything contestable at the visual level is a nightmare, but making anything uncontestable is a constraint. So making everything conditionally contestable, but you can hide the fact that it's contestable until relevant. That for me is one of the essences of topic mapping, and why I'm so sanguine about it. Now I'd like to come back. That's a bit of a parenthesis. I'd like to come back to where we were, the question of what you call centralizing arguments.
The layers.
Yeah. I don't know if you heard, you weren't there, right?
But I watched all recordings yesterday or 2 days ago.
Okay, so you know what I'm going to say then.
No.
Maybe you have some. Okay, the notion that on the one hand, taking all the premises as a blob. I see its use in some UX, but I don't see its, if I receive that as that, I wouldn't know what to do with it. A. B, grouping set of linked arguments I see as useful in its own right, especially if we ever want to be compatible with things that assign roles to premises like argument schemas. So I'm much more inclined now to say, and even that this is obviously another layer, and as I said, even layer beyond my scope right now. I do see the point of having linked argument groups in the base layer or even as the base layer, even though I understand perfectly the need for a view which just takes all those premise groups or arguments and extracts a view where all the premises are lumped together, as in your interface. But I'd see that as a view. And if
so, I already commented on this after several meetings ago. I mean, yes, that works, but you're assuming a read-only view. The problem arises, so that fully works. If it's isomorphic, that works. The problem arises, how do you modify that view? Like, because there's no mapping to modifying, adding stuff to that view. What does it mean on layer 2 level? That's where it breaks.
Absolutely true.
Yeah.
But it comes back to the fact that we can do the editing on linked argument aware
but
applications, and we cannot do it on a linked argument unaware application.
So
like
you're saying in other words, the base layer becomes read only, and you can only do operations on layer 2.
Well, I wouldn't call it base layer. I wouldn't call it base layer. I would call, because for me the base layer is
there is no base layer. It's a view on the layer 2 that's derived of layer 2, and that's the problem, because you remove the whole point of having it as a separate layer, which does not require an agreement on layer 2. That is the problem.
But what I'm realizing is, the reality is, if you edit at your layer, at the linked argument unaware layer, I won't know what to do with this edit.
That's the point. That's the point. And you decide on an individual per layer 2 level what to do with them. But it's that layer that you can actually also add stuff that goes outside of specific layer 2 formalisms. So in the last meetings, you asked, like, what is the value? That is the value. If you don't know what to do with it, then you can just say, well, there are linked claims here that fall outside of these assigned roles. For example, if you adopt Walton's argument schemes, other claims are added because maybe people are arguing the argument scheme is invalid. Where do you place them? The whole point is, once you want to argue, you want to add extra content, you can hide it, but you can still show, well, there's other stuff in the base layer present, or you can simply direct to the base layer for people that disagree with a certain layer 2 representation. And what you get is that all these claims get linked. You might have the claim modeled in the base layer, in the layer 2 of using Walton's argument scheme in one article or in one database. Somebody else.
I even called this layer 3 the Walton schemes, but yes, that doesn't matter. But
formalisms, and somebody else might do it differently. But what you have in the base layer, they all come together because you have this very fundamental. How is it related? Is it relevant or not base layer? That's where the power comes in.
Yeah, okay. You're arguing I can do something with it, and I'm not convinced, but I'm not against it, and maybe I'm open to thinking more about it, absolutely, because it's possible I think of UX cases where I get this argument in the blob and it becomes a question of, okay, where should I put it in the linked argument layer? Let's call it the linked argument layer. But what I'm thinking is at the level of data modeling, and I don't want to go in the what's the base and what's, well, I am really. At the level of data modeling, I'd say linked data sets are something that we all understand can happen. And it turns out that some applications, meaning yours, will give us one data set, which will say explicitly no information on linked data here, on linked claims here. It's just, I'm giving you a blob. It makes no claims about linked data. And that's one linked data set. It's just how you represent linked data set as only one unit.
No, you don't represent linked arguments in a base layer. That's my point.
No. What I'm saying is, if you think of the base layer, not the way you understand base layer, but the base layer of the data representation, okay, as being aware of the notion of argument collections, right? And some of us will make, premise collection. And some of us, or compound claims really, some of us will make premise collection that correspond to linked premise sets.
In a layer 2.
And we'll say so. No, not layer 2.
Okay.
We will make, I'm saying base layer is aware of sets of premises.
Okay.
Right? Okay. We will make multiple sets of premises and we will mark them, and maybe that mark will be a layer 2 mark, that's fine. But we will mark them as those actually correspond to linked premises. And that's a mark, and maybe a layer 2 mark.
So you're storing linked arguments in the base layer, yeah? Okay.
I'm storing linked arguments as sets in the base layer.
Mm-hmm.
And you will store all your arguments in another set in the base layer, saying these are all the arguments in a premise set, which explicitly does not say anything, or maybe implicitly even, I'm fine with that, says I am not making any claim about how these premises are linked.
Yeah, so that would be each individual premise in a set with one item in it.
Yeah.
Added as a separate premise set. Yeah, okay.
Yeah. And what I'm saying is we can exchange at the layer where there's multiple sets, right? Some of which are guaranteed to be linked, some of which are not, but they're still sets. And there's still multiple set as part of the common data language. But I know that when I receive something from you, it does not make claims about linkages, and hence I assume the claims are not linked.
Yeah, but the problem
I may get other things, and I still need to construct a view where I unify everything. And most likely, the unification will correspond to your blob set, because you will take whatever you receive from other sets and put it in a blob set. And I'll get that in the next update, and that's fine.
Yeah, okay, but again, how do you modify? How do you know which one to modify? That's do you if you want to add a premise, which one of the let's assume you have 100 premise sets all targeting the same conclusion. Where do I have to read all 100 to decide? How do I know which formalisms these 100 use? How do I know which one of the 100 formalisms I agree with?
Either I'm aware of linked premise and then I can make a decision accordingly, or I'm not aware of linked premise and I'll just add it to the blob, which precisely makes it clear it's about not being aware of linked premises.
Yeah, but then what's the added value in a base layer for storing them as sets?
So that it becomes easy to add concepts of linked data to those sets that correspond to linked claims.
How is that easier? How is that easier than in a layer 2 saying this set of premises that's stored in the base layer and you point to them and you group them and you formalize them? I don't see why is it easier to store it in a base layer?
It's easier because what I'm saying is multiple sets will travel in the data bus anyway. So the question is, all applications should be aware that they may receive multiple sets. And saying it's always a blob in layer 1, it's like it's about telling some applications you may receive a single blob, or maybe sometimes you'll receive single blob at one layer and multiple blobs at another layer. What I'm saying is let's all assume we receive multiple blobs.
No, I don't want to assume that. What are you visualizing? Because if you're visualizing Walton schemes, yeah, you're expecting blobs, and then you'll have a layer 2 that knows how to deal with those, and that it will know how to deal with the roles and all that stuff. Yep. And then, yeah, you're not rendering a base layer, you're rendering a layer 2, but it might still,
3.
Or 3, whatever, I don't care. It depends how you model it. The point is that the operations, they gets stored and centralized also in a base layer, which is where the centralization happens. But yeah, you will be working on layer 2. But I wouldn't say that all applications receive sets. My point is that you don't. If you want to just only look at the base layer, you hide the notion of sets. You don't have linked arguments. You don't have multi-premise. You don't have.
Well, then you only look at the blob.
Yeah, but what you can do from there, though, and that's why I did agree before, it is useful in a base layer even to have a notion of there are different layer 2s, and that's where the abstraction comes in, that have used these as sets, and you can link to them specifically to different layer 2s. And then the abstraction there is indeed just the set, but I wouldn't make that the core data structure. That's more like an external link structure, where you say there are 100 arguments out of this 100 arguments out of this core data structure. These are the ones that are commonly grouped together, for example. And here, if you want to group these 3 together, these are the 5 arguments we link to externally in different layer 2s that have grouped these 5 separate premises together. Stuff like that I see the use of. But I wouldn't store it as such in a base layer.
I see what you're saying. What I'm saying is, and this is really a question, and there I'm being a bit less sanguine. When you say you're only interested in, you're not interested in link claims, right?
I am, but not on the base layer.
No. I'm saying one application says, I don't know how to handle link claims and I don't care about them.
Yeah.
I as an application cannot interpret layer 2, okay,
yeah.
which is a valid use case.
Yeah.
We've all agreed it's a valid use case. Is it something that, and here I have no opinion, that you can tell the transport layer, I'm not receiving these structures at all, or I'll receive them and I'll ignore them. It's not that important, but you see what I'm saying. Or I'll receive something else and I'll interpret it. That's really the question. Is there, I'll receive
interpreting it always requires an understanding of the layer 2, right? Correct?
No, it requires understanding the notion of sets of the layer 2, like that there's distinct sets and that you have
okay,
to
so the only abstraction you can interpret is indeed on the base layer is the notion of sets, which I said, yes, I can agree with that.
Okay.
But my only point is I wouldn't store it like that, because it doesn't solve the problem. How do you add to the set? Because the abstraction of adding stuff to the set on the base layer is not based on groups. It's external layer 2 sources that link groups to the base set.
I understand what you're saying. Yeah. I understand what you're saying. And I'm saying let's have both. Let's have the blob set and the precise sets. But maybe that's redundant.
I think in a way, depending on how you interpret it.
But anyway, that's what we're
anyway. Agreeing on. Yeah.
But that's what we're doing anyway, right? It's redundant. The question is, you want to filter out, but that creates.
I would link. Let's put it this way: in the base layer, yes, I agree. I would also group sets, but I would link those to the basic storage, which is just not as sets. So basically, for me, sets would be external links to layer 2s, an abstraction where we simply use URIs, and that links to the premise IDs. I wouldn't store sets as the central data normalized form. My normalized form doesn't include sets. I just have all the pros, all the cons, and then you can also store groups inside the base layer, which simply points to the IDs of the pros and the cons.
No, one second. That is a set, right? It's a set of pros and a set of cons.
It is, but it's not a base. It's what do you call it in RDBMS?
It's a joint table.
Yeah, exactly. So
it's a many to many. Yes. Which is what I'm calling a set at the.
Do you see the distinction I mean by I don't want to store sets as the core data structure? I don't want to store a set and store another premise, another set with a single premise.
Well, in a way, we'll have to, because okay, so I think we're coming to an agreement. I'm not sure whether there's a small disagreement here, and I'm not even clear on whether I care about it so much. But we agree that the whole set is a thing, and the small subsets corresponding to linked premise subsets are a thing, right? Which you would put in layer 2, which is, I mean, the question is, it will go on the wire. Clearly, the first, what I call the blob, the big set of all premises goes on the wire. That's agreed. So they both go on the wire. They both exist. There is redundancy because, in theory, the blob could be derived from the sets, but you don't.
Well, no. It's not in practice. It's not possible because you can no longer support write operations on a base layer and a layer 2 agnostic. You can, if you.
Yeah. I see what you're saying.
That's why in practice it's not possible to do that. If you want to support write operations on a base layer in a layer 2 agnostic fashion,
actually not true, Stephen. You could, if you're layer 2 agnostic, you could do other premises as singletons.
Yeah, but what type is it?
That's isomorphic. That's equivalent. If you say you either have sets or singleton sets.
What would you link to? Because remember that I would group to a layer 2. What would you link to layer 1? Like the external link is 0, or?
What I'm saying is, okay, you have, okay, the conclusion is that we have premises A, B, C, D, E, okay?
Yeah.
And we know that A, B is linked, like it's either A and B or C and D or E, okay? So from my viewpoint, you'd have one premise set AB, one premise set CD, and one premise set E. And now I find, oh, F could also be a premise, right? And I'm layer 2 aware, so I say, oh, where does F fit? Is it linked to anything else? And if so, I'll create sets accordingly. But if I'm unaware, it's like, I don't know, so I'll just add it as a singleton premise, like E. It's F is somehow related. I'm not saying it's sufficient. I'm just saying it's a premise of Z. And the blob view is constructed of take the union of all the premises. And in your layer, in your application, instead of having the blob as an object, you'll have a bunch of singletons and create the union.
So why do you do the external linking to layer 2s? For me, that would live in the set. Like when you group premises, I want an external link to the thing that does the additional formalization. For me, that would live on the group.
Yeah. It would be extra properties on the set.
So what would that be in the case of a single premise where you don't have a layer 2 formalism?
When you don't have a layer 2 formalism, the formalism is absent. That's the point of progress.
So, but now you have like this. Yeah, I mean, it's one way to model it. At this point, it's isomorphic, but
at this point, it's isomorphic. That was exactly my point.
Yeah, but I think it's a bad model. I mean, that's sure that works, but I don't see the benefit of it.
Fair enough. That's worth a different kind of argument.
Because you're basically saying this abstraction, this group, is two things. It's both something that has a layer 2 formalism and that doesn't have it. I'm just saying, well, I just store all the things that don't have layer 2 formalisms in the base layer and then link, like you have additional modeling, which links to any additional layer 2 formalisms. And your finger modeling, the premise set, is much more consistent. It's not two things. And that's why I prefer that model.
No, for me, this is the OO substitutability principle you're saying, right? Yeah. Either the group is the subclass which has the layer 2 information, or it doesn't, but it still has the set information in all cases. The superclass is the set.
But, well, it doesn't, because what is it? You have no clue what the set is, other than you need the layer 2 to understand the set. That's what I'm saying.
That's absolutely true.
So that's why I'm saying, if you're going to model the set, then the reference to the layer 2 is not optional. It should be mandatory.
But the reason I think it's still worth it is that there can be multiple versions of layer 2, like different logic systems. Mm-hmm. And I may be aware of one version, not of another. Mm-hmm. But it still makes sense for me to be aware that these things are grouped, even if I don't understand how they're grouped.
But that's still supported, right? Because you said it's isomorphic. So you would just have, let's suppose you only have A and B. In the base layer, they're simply two separate supporting claims. Mm-hmm. You have two sets of A and B, one with one formalism and another with another formalism, both of A and B. And you know A and B have been used in two formalisms in two separate layer twos, and you have the link to layer two.
Yeah.
Like, what do you gain by storing this in a base layer as? Yeah, that's the question. How do you store it? And that's what I call
I'm saying, I'm saying as a singleton premise. And okay, my problem.
So you would store it as A and B with formalism 1, A and B is formalism 2.
Yeah.
And now my question is, where do I add my A and C? Do I just add my?
You do it. You're presumably, if is by you mean your non-layer 2 aware system. Well, it will just say A and C as a group without formalization. The base class,
or I add A and B separate, and yeah. I mean, yeah, it's isomorphic at that point. It is.
Okay, the reason I tend to prefer this, it's not an important reason, and there's an argument there, is that otherwise, when I'm adding an argument, suppose it is a singleton, right? It's a sufficient premise. Then I need to add it both as a singleton because I'm layer 2 aware, and add it in the blob. So I need to add it in two places. So there's an anti-dry aspect to it.
Well, yes and no, but the user wouldn't do that, right? The point is that layer 2 maps operations to a base layer. So if you add it as a singleton in layer 2, it gets added correspondingly to a mapping to the base layer. You don't have to do that as a user, right? If you're layer 2 aware,
I never said as a user. I meant as a data structure.
Yeah, but that's the benefit. It's a benefit. You call it a downside. I call it a benefit, because by doing that, by adding the mapping to a base layer, other layer 2s also get the data. That's the benefit. If you don't do that and you only keep it in a layer 2, you need to understand the layer 2 formalism to get the data.
You don't need to understand layer 2 formalism. You just need to understand the set nature of layer 2, which is simple.
That was a bit my point, I think. I'm trying to follow you guys. You're like pretty fast, but what you basically agreed on is that in layer 1 you have all the claims, and then you have a notion of sets of claims, right? But as far as I understood, no labeling or whatsoever on these sets, so it's just a nameless set.
That's what I'm proposing. Yes, yeah. It's not what we agreed on, but
it's what I'm proposing. No, I think we agree on it. The question is, where does it live, or how do you model that? It's really a software engineering modeling discussion at this point. I think
yes,
conceptually we agree.
Okay.
Yes.
And then layer 2 references these sets and gives it meaning, right?
Correct.
That could be one option.
Yeah, and with this meaning, even in layer 1, you could add stuff to the set, and then it appears in layer 2 in that set. Is that also something you said or not?
Okay. Let me try to redo it. We agree that conceptually, there's a set of all premises, right? So there's two ways to represent it as a software engineering problem. And I agree, at this point, it's a software engineering discussion. We can have set, what I'm proposing first. Or no, let's first start with what Stephen is proposing. There's a layer 1, which is the set of all premises. And there's layer 2, which are explicit subsets, which live independently. And layer 1 doesn't have to even receive them, which say, here are this premise taken from that big blob set with added structure. So that's proposal 1. My proposal is, let's have just the layer 2 sets, but the structure is optional. What is not optional is their set nature. Here's a set of premises, and conditionally, for an application that's layer 2 aware, how these premises are related. So if you want to get the blob, you just do a union of all the sets, which is simple to do.
There's also an option 3, by the way, the one that I was arguing for.
Okay, cool. If you're not layer 2 aware, what you do when you add a premise is add it as a singleton without formalization. You're saying this premise is relevant. I don't know how it connects to other premises. And so you'd have a lot of small sets with optionally structured, optionally interpret, like logical formula on each of them. But each set would correspond to, if there's multiple elements in the set, there's presumably formula, because it would presumably be made by a layer 2 aware.
Actually, a quick way to sketch this is just make 3 class definitions actually, because it's quick to mock this up. It might make it more clear in the language. But the third option
Could you do that,
is
Steven? Could you do that?
I can actually. Let me try to.
And we can use that as a summary because we're almost at the hour already. Yeah, that was quick.
Sorry, we went into
Untitled notepad. Okay, option 1. You have a let's call it an argument. You have let's call it claims. And a claim is nothing more than a statement, we call it, right?
Yeah.
Yeah, that's option 1, correct, Michael?
You'd also, I would add the it depends claims.
That's not part of this discussion, is it? I mean, I don't
No,
disagree
it's,
there,
it's
but
true. It's true. It's not part of this discussion. Fair enough.
So yeah, this is necessarily incomplete. It's just to make the point. Option 2, I'll go with one that Michael Twan just said, being an argument. But argument is a bad name.
Yeah.
Like more argument set, argument
support.
argument collection, maybe. And then a conclusion.
Yeah.
Does that work?
Yeah, for now it's good enough. So that would be layer 1, and then we'd have layer 2. But anyway, go on.
Claim is independence. That's always the same.
Yeah.
For all options.
Option 1. So this argument collection is layer 1.
Option 1, layer 1. Base layer, we called it mostly, right?
Yeah.
Although I still don't like that name. I'm starting to considering it the relevance layer, because it's all about just finding claim relevance and less about argument mapping.
Fair. I see what you're saying. I do like this.
Argument collection would be a set of claims, which would then be arguments of type set of claim. Sorry that I am switching notation here, but
yeah, I would not materialize the argument collection. I would just have argument.
But what is an argument?
It's pretty much as above. I think the difference is really that it's not the base layer that's different. Okay, it's not.
What I understood is that you would sort of sets of claims.
Okay, the difference is that it's the same model as above, but there's a notion that in the base layer, for any given conclusion, there's only one collection. And in my case, for any one conclusion, there's multiple collections.
Yeah,
and so I would call it
set
argument.
is a collection here, but there's multiple, right? So arguments.
No.
Oh no, I got you. Okay, so we need a new entity for that. Arguments, which is basically a set of claims, and then arguments.
It's like your argument collection. The structure of argument is like the same structure as your argument collection.
Like this?
Yeah, but the argument has all the conclusion, supporting, opposing as your argument collection.
Yes.
So just copy paste the terms of argument collection, put it on the.
So you within the set, you still know which ones are supporting and opposing, you mean?
Possibly not, but yeah, I guess. But at least
we didn't talk about this, right? It's interesting that that's something we omitted in our discussion.
Yeah, and we did. Let's just put set of claims and conclusion. But let's say that I don't want this to be the difference. I don't want this to be. This is not the difference between our two models, right? So let's use your structure for now.
The difference is the fact that you group them as a.
Yeah, but see, this argument collection, you're assuming it's materialized. I don't. It's just a fact of life. When you're looking at a conclusion, you can compute the collection, but it's not an object in the system. It's a result of a query. You query what are the arguments that share this conclusion, and you get a collection of arguments. It's a query result. It's not an object.
Yeah, okay, then tell me how you want to store them.
I'll have, you want me to do the table diagram? I
No,
have,
I understood that this is what you wanted to store. You want to store sets of claims, essentially.
no, I don't want to store the set of claims. That's what I'm saying. It's a query result.
But
So-
which set are we talking about? Are we talking? How would you represent the linked argument, a linked argument in the base?
In the
layer?
argument, each set of arguments is in the argument structure. I would like, by the way, please add the conclusion to the argument because it will make things clearer.
Yeah, that's true.
Thank you.
I'll add it on top.
Sure.
So is this not what you mean?
This argument is fine, and
Okay.
the difference between the division of supporting opposing is not the point of the conversation. So maybe we have supporting opposing, maybe not, but that's not the point.
So I'll remove this.
So, yeah. Now what I'm saying is argument collection for me is not necessarily a materialized object. It's not necessarily.
Oh, because
stored.
yeah, okay, you can find it because of all the ones that target the conclusion, basically.
Yes.
I mean, but that's
Yes.
yeah, okay, got it.
Yes. Thank you. That's what I meant. It's a class method and argument.
At the top, when you're saying conclusion claim, supporting claims, opposing claim, is it basically a set of claims with links between them?
Yeah.
Okay.
Okay.
Yes. Yes.
Now what I mean is this.
We should show the other layers, but that's okay.
Yeah, I
Later,
think we
later.
mostly agree on layer 2. Well, we agree on the fact that there needs to be one. So I would do like this, and then
This all
something along those lines.
all these options assume all that our model of claim, support, and so on is the simple one we came up with so far, right? It doesn't include anything else that's on the horizon, like
Well,
context or whatever.
okay, here's we'll get it. That's true. That's absolutely true. But let me sketch things about layer 2. In option 1, basically, this argument, which lives in option 2 base layer, becomes the layer 2 of option 1, right?
Sorry, okay. What are you talking about?
Okay, the argument structure that you have in option 2 base layer, that becomes the layer 2 of option 1 also.
The layer 2 of option 1.
Yes. Or actually, let's first have option 2. Let's first do option 2 layer 2.
Okay.
Option, that would be formal argument, extends argument, and which adds formula. And it, okay, so that's basically, so what this option 2 layer 2 would basically also be option 1 layer 2. It would be the same thing. In option 1.
Yeah. Well, yeah.
Yeah, okay. So the layer 2 is the same. The question is, do we have this argument collection materialized or not? That's really the question.
But you have it, you also have it materialized in option 3, right? Because
okay, I'm trying to understand. I'm trying to understand option 3.
Yeah. So you materialize it, but it links to layer 2. Because as we both agreed actually before, you cannot interpret the set without understanding the formalism. All you know is that it's a group, and yeah, that's useful in a base layer. I agreed on that many meetings ago. So I do agree on storing the set of claims, because it's very useful to have all the references to different layer 2s, even competing layer 2s, with the same set of claims. But I would store it like this. I wouldn't store it's basically the the normalized form, if I'm not mistaken.
I'm still not understanding how you construct your option tree. Sorry. So I will ask
What do you mean by
questions.
construct?
I don't understand what what is in your argument layer 2 reference. Sorry, you think it's not clear to me. So I'll ask questions. When you say URI to layer 2, what part of layer 2 of what? The option to layer 2? Well, we said it's equivalent to option 1 layer 2, but so I'm trying to see how this is different from layer 1, frankly. Because
Well,
if you have,
it adds
because
this.
no, if you have a link to the option 2 layer 2, the claims, the set of claims is already in this option 2 layer 2. It's already there. We said there's a set of claims.
Yeah, but this is a competing option.
I'm trying to see how it
competing with
competes.
option 2, so pointing to option.
I'm trying to see how it competes. What I'm saying is, if you have, when you say URI to layer 2, I'm assuming that you mean layer 2 as defined in option 2, or maybe in option 1, but we said they're the same.
Well, it's a URI.
URI to what?
It's a URI. It's
okay. URI to what? URI, it's a reference to something.
To whatever,
right?
Yeah. It can be, even if you believe layer 2 is Google, then it will be Google. I mean, it's a URI.
How is that layer 2? Okay, so I'm just, okay, what do you mean by layer 2 in this? When you see URI to layer 2, what do you mean by layer 2? I don't understand what you mean by layer 2 here.
It's what base source that defines that argument. And it's that web source that defines how to interpret it. The additional information on how to interpret the set is defined by this external link. That's what it means. So if you have two competing sets.
Okay. What you're saying is, instead of having the formula in place, you'd have the URI to a formula.
Well, the formula in place is impossible in a base layer because you don't have.
No, but this is layer 2. We know it's layer 2.
No, this is a base layer.
Oh, okay.
There's,
argument layer 2. Okay, now I'm beginning to see it.
So base layer points to layer 2.
Exactly. Yeah. That's the usefulness, the fact that you can link multiple. That's a centralizing disagreement and arguments. You can link multiple groups of stuff from a base layer to external sources.
Okay, but I still maintain this is very much like my option 2. I think it's exactly equivalent, because your references, they contain a link to the claim. So that's exactly what I have in argument, set of claims. And they have a URI to a layer 2, which is pretty much my formula, except it's a URI to the formula instead of the formula itself, but same difference. It's a point, it's a ref instead of the by reference instead of by value.
I assume you would also either way want this, because otherwise you're stuck.
No, no, I don't.
Okay, how do I go from the base layer to different layer 2s?
Oh yeah, I would have, URI or say, okay, if there's different layer 2. Yeah, you're right. That's true. Okay, fair enough.
And with different layer 2s, you mean, like, for example, different web applications, right? For example, Socrates and, for example, Gullybot.
Okay,
right?
now I understand what you're doing. Okay,
well,
fair
it's
enough.
not necessarily web applications, right?
Or like in general, like systems that some
layer 2 decides basically.
Whatever.
Yeah, it could be a blog post actually. It could be a blog post that simply writes those arguments, and these are all the premises used in the blog post.
That's correct. We said text was a valid pre-formal version. I'm happy with that. Okay, now I understand what you're doing. Use this to interpret blah, blah, blah. And it may or may not have the formula information.
Yeah, it would make sense. I mean, I'm of course, it could have a schema or whatever, yeah.
Well, I thought you were right to layer 2 was more the schema.
Yeah, I don't have all the details here. It could be, but it would definitely also be some readable link, not only the type specification.
And again, we're back to, sorry, your option 3, besides the reference or in line, it's exactly my option 2.
It's a denormalized form, a normalized.
Oh no, you materialize the collection.
Exactly, because that's the main thing, and then the additional.
So it's exactly equivalent to option 1 then. I don't see the difference between your option 3 and option 1.
But this is.
Your
option 1 doesn't have the references to layer 2.
Exactly. I mean, it's a pretty easy diff, no?
Yeah, well, okay. So it's option one, where the with the layer 2 information stored in the base layer.
Except that it's not the layer 2 information. It's only the notion of the fact that it's a group of claims, and you link to the external information that knows how to interpret that.
Yeah, but then you have the layer 2, which is adding the formula to everything else, right?
Exactly. And it can do whatever. Like I said, it can be a blog post. It can be that's up to layer 2 to decide what to do with that set of claims.
Yeah. So again, the question there's. This is exactly like the question. The only question is, do we materialize the collection, or is it the result of a query? That's the only difference.
Yeah. As I said, it's isomorphic, but this is just for me, the most sane way of storing it, because otherwise, I mean, then you always have to, the use case of the base layer is this. So if you store it otherwise as sets, then
the use case of the base layer is actually just the first part, right? Or as you understand the base layer.
Yeah, but I mean, this is also useful. The fact that
of course
you can,
it is. Of course it is.
I never denied that it's not useful to know which are the common sets of premises that I use together. That's definitely useful information that can be derived if we store it in the base layer. And that's why I definitely agree with you. Storing this in the base layer makes sense.
Right. And basically at this point, saying the version, it either has or doesn't have see, when I'm saying in my option 2, right, formal argument depends on argument. Like even the schema could depend on which formal subclass we're using. So the schema could become implicit. So what I'm saying is we have a bunch of objects which are either the not quite abstract superclass, well, let's call it the minimal superclass, which has just the set of claim IDs. We could have a version that's a bit smarter and has a URI to an explanation of how they're linked, which is the text, the text argument. And we can have a version that's according to schema X and using this formula, formula interpreted according to schema X, and that's another subclass of. So either way, we'd have the argument type, which would implicitly carry the schema and which would have minimally the conclusion, the set of claims, and possibly a formula interpreted according to the schema, or the URL to text, or the text itself, or whatever, right, depending on subclass. And so those are carried, and I don't think it's that useful to separate the transport of this. It's just the interpretation is different. If you're not aware of the formal subclass, you're still aware of the sets of the common properties of the superclass, which is the set and the conclusion.
Yeah, but that's all the set is. All the set is the fact that it's a set.
Yeah, pretty much.
So you still have that here as well.
What I'm saying is the schema would be in the implicit in the superclass, in the type, and what you call URI to layer 2, it could also be for some subclasses, or it could be common. I don't mind having that common. I think it's a good idea, actually. Did not think of that.
You don't forget, you need the URI to the actual argument, right? The schema information is one thing. You need the actual link. Like if you want to have a system that can interpret this formalism, this is where you have to go.
Well, or it could be in line, right? As in my formula. It could be a URI or it could be in line. It shouldn't matter.
What do you mean by inline?
Human readable or machine readable? Inline.
Either. What I'm saying is either you have text explaining the argument, or a formal formula parsable explaining the argument according to a certain schema. Either way, it can be a literal, or it could be the URL which they referenced will give their literal. Same F difference.
Understand, yeah. There could be like another example would be the whole blog post is embedded in there, right? The text, whatever.
Yeah, same difference.
Okay.
You have the description of the argument, which can be inline or a URI. And yeah, that's a valid distinction. For me, they're all URIs, by the way.
But then how do you know how to interpret it again based on the schema? So again, you're not layer 2 agnostic.
If
The whole
what I-
point of storing something in a base layer is that you understand what this is, regardless of what layer 2 is.
Yeah, but if it's pointing to a blog post, then you still only like there's no difference in to know how to interpret it.
No, there is. If you can
follow the link or you don't.
okay,
you
no,
can only
I understand your
interpret
question.
this
It's a good
thing by
question.
knowing what that is, then you basically are breaking Liskov substitution principle, which is my main pet peeve.
No. That's okay. Okay, for me, the formula is in a subclass. So the idea is, if you have the subclass, that means you know how to interpret the formula, and you have the schema, and you know how to interpret the formula. The schema is
then you're already on layer 2, right?
We're on layer 2.
Yes,
it's a subclass. But the idea is we communicate the same object anyway. We communicate the object which happens to be the base class or a subclass. And if either way, it has the base fields of the superclass, which is only this. And maybe also URI to layer 2. I don't mind. Now, the real question you're asking, and it's a valid one, do we allow a formal representation which does not have an informal representation? That's a good question. I did not think that far. And this would be, and that's a question of, do we want the reference to or inline, doesn't matter, linguistic representation to be mandatory? Or is it either linguistic or non-linguistic? Or do we always require the linguistic layer? I'm open to that discussion. I don't have a strong opinion. I would tend to allow either linguistic or not, and not require the linguistic layer. But certainly the notion that the set is what is always interpretable, we agree. There's always a representation of the argument, which may be formal or informal, according to one possibility, or always informal and maybe formal, according to the second possibility. That's a good question. It's a real.
I mean, it basically arguing something along those lines, which would be useful indeed.
No, that's not what I'm arguing.
Okay.
I'm saying there would be URI or basically, whether it's a URI or not, let's forget the URI. There's human readable.
But the URI is relevant because that points to a resource. The question is, what is that resource?
No, what I'm saying is whether it's a URI to a resource or the resource is in line, that's irrelevant. Okay, but there's a human readable version text, and it may be a reference to text or text ref, text or URI to text, shouldn't matter. And okay, so we have text, human readable text, or reference to text, I don't care. And the question is that optional? Is it?
Of course, it is. The whole point of separating layer 2 is that it can be whatever.
I'm not sure it's an of course. The question is, do we mandate that the formal representation has a text human readable equivalent? It's a good question, I think. I wouldn't, again, but it's
I wouldn't, just like I wouldn't mandate that it has a formalism.
That's correct. I think, okay, so I think we agree. So in which case, I would say human readable version, optional text. And then in certain subclasses, we have the formula, because and then it's mandatory because we're in the subclass where that formula is interpreted, and the schema is derived from the subclass. It's a class variable of the subclass. And then we don't need URI to layer 2 because it's either the text, which again may be a URI to the text, it doesn't matter, or it's the formula, which may be a URI to the formula.
How do you know which one it is?
It's different variables. You have the variable in the superclass human readable version, optional text. That's one field, which is always there as a field, though the value may not always be there because it's optional, but it's always there as a field.
Yeah.
Okay. And that would be in the base class. So that's the definition of argument.
Argument what? Arguments?
Yeah. You have the conclusion. You have this, the set of claims.
The link or?
Yeah, make it the set of claims. The fact that it's a reference, by reference or by value, I want to. That's a separate conversation. Set of claims, one way or another. Okay.
Now what?
And that's it. And then you have formal argument or
You don't see, why do you store the formal argument?
That's not
in the base layer.
No, that's not the base layer. Then we in the layer 2, comma, we have formal argument. Formalism 1 argument.
Yeah.
Schema class variable. Class variable, because if you have a different schema, you have a different formal argument subclass. You have formal argument 1, formal argument 2, formal argument 3 with, or schema 1 formal argument, schema 2 formal argument, schema 3 formal argument. Yes, that works. Yes, that's it.
So I'm on the base layer. How do I go to layer 2?
Because you've received a layer, you don't go to, you've received an object which may be either of the superclass or of the subclass.
So you're storing you're storing layer 2 in base layer.
Yes.
If you're doing that. Yeah, but
yes.
No, no, that's what I'm saying. No,
that's what OO allows. OO makes it clear that you can.
I mean, yeah, you can store this in a MongoDB with in JSON and something along those lines. Sure, you can have some serialization and ingredient serialization and store whatever, but
okay, in the database,
you no longer have 2 separate databases, right? You have 1 database.
You have 1 database, yes.
Yeah. So
and you have 1 channel, and you have, what I'm saying is I don't see the point of having different channels. I see the point.
Well, you don't see the point of having different databases, apparently.
No, I don't. No. Okay. But I see the point. Yes, in the sense that your application will have its database, and my application will have that database. Basically, your application will ignore it's formal argument. I don't know what it is. I don't know the formula, but I know it's a subclass of argument, so I'll store the argument.
Yeah, so you're saying the formalism is stored in the base layer. So you're basically saying there is no base layer. There's only a central database. If this is what you want to do, there is no distinction between a base layer and a layer 2. You store both of them in the same layer.
I store both of them in the same layer, but an application may be only relevance aware. So when it gets a formal argument, it just looks at it as an argument.
Yeah.
Because Marc-Antoine thinks of it as data you can subscribe, right?
Yep.
Not in terms of a central database.
Exact. I think of a data bus. You subscribe, you receive events, and you receive these events, and you interpret them according to how much you know how to interpret them.
And you ignore some if you want.
And you ignore some.
Yeah.
Okay, but then I don't understand why you've been using the language as base layer and layer 2, because this for me is 1 layer.
There's layers of interpretation.
Yes, true. Yeah, okay, so I'm obviously arguing against 2 separate databases and separate systems that run on separate servers and whatever that all talk to a base database.
I mean, you can do both, right? You can use the data bus Marc-Antoine is describing and say, okay, we have.
But you can also have a data bus on.
Instead of 2 databases, we have 2 separate events that reference each other. Then you can. That's isomorphic to having 2 databases.
I'm a bit agnostic about how your application stores things. The question is, what travels on the wire between our
You're
applications.
not, because you're gonna have to enforce a serialization mechanism. You're gonna have to enforce a storage mechanism to make this work. And yeah, JSON and MongoDB will work, but or any document store for that matter.
No. Okay. I don't even think that's true, but I do kind of see a point. Here's how. I could see your application receiving the formal arguments, downcasting them to arguments, and only storing the argument data, right? You're not storing the formula, it's fine. But the argument has an identity, presumably, which is universal, kind of URI, which means that, I'm thinking of it as an IPFS identity or whatever. So the formula is text, which will be parsed by the schema, according to the schema.
So you serialize everything as text, which again, you're mandating like a serialization mechanism in.
But again, that's schema aware. When you know the schema, you know how things are formalized.
Then you need to know the serializer. And
And if you don't know the schema, well, you don't do anything with it. And it's possible it's not text. It's possible it's JSON or whatever.
What if I want to attach videos? And what if I mean, I just don't understand why you would want to do it this way. Also from scalability perspective, why do you want to store formalisms that the base layer does not interpret in the base layer? What advantage do you gain?
Okay. There's why do you want to store? I'm saying you don't have to store it. A. B, why do I want to transmit them? Because that's a valid question. It's because I don't want to transmit them twice, once as with the layer 2 data and once without. So I'll just transmit it with the layer 2 data, and you'll just interpret the layer 1 if that's the only thing you care about.
Can we agree that you can only interpret the layer 2 data if you're aware about layer 2 formalism?
We agree totally. But you can, one second. However, you can interpret a layer 2 event as a layer 1 event if you don't know layer 2.
Are we talking about the difference between a reference and embedded data right now?
Well,
not sure.
Now we're talking about whether or not it should be one layer, a base layer, and a layer 2.
Yeah.
It's interesting because I mean I thought it was clear that I wasn't talking about layers of interpretation. Of course, it's also implied if you have architectural layers, but I was talking about architecture, like different architectural layers and communicating systems.
Okay, and I kept saying we'll have a common data model and we'll be transmitting that data model and we'll interpret it according to our capacity. So interesting misunderstanding, but yes. And in a way that
so what are the benefits of, because I understand, so you want to have some polymorphic, and that's actually what I'm doing for work. So I know that's possible and it has benefits, but what is the benefit in this case for storing arguments that you store the formalism in a central database?
What central database?
Your base layer or layer 2, whatever, it sits in the same database, and you can store the formula side by side with the sets.
Right? If I'm layer 2 aware and my database, there's no central database, but if my tools database cares about a particular schema, then it will store the formula and it can act on them. Of course, it wants to store it if it's going to do something with it. Why don't I separate it from the other one? Because why would I separate them if for me they come together? It's a subclass.
So you're saying that the events across systems should include the formalism?
If for those who emit formalism, yes.
Well, but you're saying that the formalism is a field that every event carries, apparently.
Every event coming for an application that knows about formalism. Your application will obviously not include the formalism. It will just give the base class, which is fine. It won't have formalism. Your application will emit arguments which won't be formal argument subclasses, just the base argument class.
Okay,
so
whether you're talking event sourcing or not, I don't think it's relevant. The point is still that you're communicating.
Yes.
If it's there, you're communicating it, and people may listen or not listen to. You're communicating something, right? And you want to communicate that on a base layer or base events you send out. Doesn't really matter.
What I'm saying is I don't want to make separate channels. I don't want to transmit things twice. I don't want to be transmitting things in two different ways.
Yes.
That's complexity. Let's just send them one. And
Well,
send them once. And according to how much you understand, you'll discard fields you don't. And according to how much you understand, you'll send the fields you understand. And if you don't send more than a certain amount, it's fine.
okay. Now materializes into a centralized canonical useful system that centralizes this agreement. How would you store it? What would that system do with those events?
Those a layer 2 aware canonical database.
No, not layer 2, because it's a it's one that stores all layer 2, so it cannot be layer 2 aware. It operates on the common abstraction. Like, what would that database look like for you?
Oh, if it's not layer 2 aware, then I wouldn't. Okay, I wouldn't. We're using canonical in different senses again. Okay.
Centralizing this agreement.
Centralized. Okay. A layer 1 centralized database will only store enough for the argument structure. It probably won't care about storing the formula. Why should it? So it will discard it.
That's the base layer I'm talking about.
Yeah, but that's.
So you're talking about the events that will be sent across the wire.
I'm speaking about the common data structure that we're sharing.
Exactly.
And what I'm saying is, if I'm layer 2 aware, I will send layer 2 events, which you will interpret as layer 1. If you're not layer 2 aware, you will send layer 1 events, which I'll interpret as layer 1 because that's all they contain. But
so
it's not two streams.
How can I consume these events now in a base layer and usefully link to layer 2s?
So the events will have the event type. The event type will be formal argument, schema, blah, blah, blah. You have to know, and that's something, there has to be a mechanism so you know that this is a subtype of argument, right? This is something that's a piece of added complexity. But once you know that, this event type is actually a subclass of argument event type, then you know, okay, well, here's the fields: conclusion, human readable, set of claims, and probably an identity. And that's it.
Yeah, but how
you read those fields, and there's a formula fields you don't know about, don't care about, then discard.
Yeah, but how do I now usefully link to competing layer 2s? How do I link back?
Because of the argument ID. The argument ID is shared.
I don't get it. What do I do with the argument ID? What do I call? Where do I go?
It's you store it. Okay, I'm thinking of IPFS like content addressable ID, but that's may or may not be true. That's not important. Or if not, think of it as a URL. The argument ID is a URL, which means it's a shared reference between everybody. The argument itself has an identity, which is a reference to the argument and possibly the full form.
Isn't that the same as I wrote here?
No, it is. Well, not as I understood it, but it's possible I totally misunderstood this. But this is not your, no, it's a URL to the whole argument. But that's not important up to a point. The question is, okay, maybe I misunderstood your question. What do you mean by how do I reference it? What's the operation you're referring to? What's the use case you're referring to?
The use case is linking. I'm in a meeting. The use case is being able to centralize this agreement because I want to be able to link the more formalized. I'm at the base layer. Suppose I have Socrates open. I now want to read blog posts. I want to see a Walton schema of like a popular argument related to this presented conclusion. That's my use case. Like, how can I usefully link from a base layer to formalisms?
Okay, fair enough. So here I was assuming you don't care about formalism, so you don't store them and you discard them. It's also possible for you to store them as text without knowing how to interpret them, and to say, well, I don't know how to interpret this, but here's the formula. But that's only matters in the case where you don't have the human readable, right? In many cases, you'll have the human readable version of the argument, which has been included as part of the argument. It's optional, but sometimes it'll be there. If it's not there, you can store the formula as text and say, listen, I was not given a human readable thing, but here's the formal formula if you as a human can interpret it. And by the way, it was using this schema because that's a property of the superclass.
I can't imagine writing the code to do all this, to be honest, without
Okay.
being layer 2 aware.
No? Okay, that's interesting.
Because
Okay.
you need to somehow, based on these extra parameters that you're saying you should ignore, decide how to do things here.
No,
in
no,
layer
no.
2 formalisms. I don't know how to interpret the layer 2 formalisms if I don't know what they are.
Okay. So you know what? You're right. So let's say that the human readable is not optional, but that you've made a point. So basically what happens is if I'm layer 2 aware application and I have a formal argument and I didn't bother to ask or you know, I asked the editor, please give me a human readable version of that formula, and the editor can't be bothered to give a human readable version. Then I will take the formula text representation and put it in the human readable field. I'll say, all I know about is it looks like this formally. Because the editor did not bother to give me a more linguistic version. So that's all I have to offer. So you will have in the human readable something that may be more formal than you want, but you'll always know to get it in the human readable. And I think that's an acceptable option. But good point. So you can remove optional from human readable.
Should we wrap up?
I
Yeah.
think it's a good idea.
Okay. I mean, I guess that was a summary.
No, that wasn't. That was not our conversation.
No, well,
Like a
I
40
think
minutes
I can post this whole text document. I don't know whether it's useful.
Yeah. It might
But
make
we
sense
at least
to write it
uncovered
down
that.
again.
We at least uncovered that the very notion of base layer and layer 2 already was being interpreted differently, at least between the two of us.
Yeah,
That's what I suspected all the time. That's why I asked for definitions or descriptions. But like one person writing it down and then having the other person look at it seems to work well to discover these misunderstandings. Okay, cool.
Yeah, progress that way.
Are you guys there tomorrow?
Yes.
I think I will be. Yeah.
Yeah, it's actually difficult because I have a conference. It's the Knowledge Commons conference. So if we could skip tomorrow for the Knowledge Commons conference, I'd be grateful. But I have other places to go, so I'll miss part of it anyway.
You mean like completely skip, or should we make a session, Stephen? Or
As you wish.
I'm up for having a different session.
okay, I'll be there.
Cool.
And I'd love to later hear more from Marc-Antoine what the big problem is with having two separate databases. Because for me, it feels natural. It's how I would build distributed systems. You specialize, but yeah, we can have a discussion about it later.
It's not two, it's infinity many databases.
Yeah, exactly. For each different formalism, you have a different one.
No, that's not how I see it.
That's not what he's saying. Yeah,
Okay.
whatever. Next time.
Yeah, next time.
Okay.
Ciao, ciao. Bye.
See you. Bye.
See you.